sixth grade scientists. So this week we're going to be talking about a property of liquid called viscosity. Have you ever thought of peanut butter as a liquid? Well, if you smeared it on the wall, and I don't recommend you do, you'll probably get in trouble, it will slowly eventually flow down the wall. Well, if you take a squirt bottle with water in it, on the other hand, and squeeze that onto the wall, the water will quickly flow down the wall. So, why does it do that? Well, gravity. Gravity is the force that pulls everything downward. Well, if you're at home and you think about the other side of the globe or the other side of the world, downward would be two different things. It would be two different directions. So actually we should say that gravity is pulling toward the center of the earth. So gravity is also what makes liquids flow. Now, if you think about it, if we had no gravity, what would happen? Well, liquids would be floating around in space, just like all other matter would be floating, because there'd be nothing to pull it down. So it would make taking a bath really interesting or really weird, one or the other. So gravity pulls things at the same rate, at the same amount, with the same amount of force. That's why, well, if you think about things like peanut butter and motor oil and water and honey, they don't flow at the same rate. Why? Well, the answer is called viscosity. Viscosity is the property of a liquid that describes how fast or how slow it will flow. It can also be thought of as the resistance of something to flow. So if you think about something thick, a thick liquid, like, say, for instance, peanut butter. Peanut butter, because it flows very slowly, has a high viscosity. Now, think about something that flows easily or quickly, like water. It has a low viscosity. So, in the grand scheme of things, a viscosity rate, everything will be related to how water flows. So, think about frozen waffles. So you put your frozen waffles in a toaster and you wait for it to pop up. You plop them on your plate. Oh, you're ready to eat. So you go ahead and you open up the fridge and you pull out your syrup and you start to pour. And you're waiting. And you're waiting. And 2 minutes later, you're still waiting. Why is that? Well, it's because the syrup has high viscosity. It doesn't want to come out of the bottle. Why? Because it flows very slowly. So it has high viscosity. Well, what is viscosity? What causes viscosity? Friction. Friction is caused within a liquid as well. So we think of friction as the resistance of two objects to move past each other. Well, if you think back, remember, all matter is made of molecules. So we have water, H2O. Those molecules flow easily and quickly past one another. Now, think about syrup. Syrup is a very complex, concentrated liquid, and that liquid is made up of very large molecules. Those molecules, when moving past one another, get tangled up with one another, and it's very difficult for them to move past each other. So because of that, it has a high viscosity, and it takes a long time to get out of the bottle. Now, you can affect viscosity with temperature. So if you take your syrup out of the refrigerator and heat it up in the microwave for a few seconds and then try to pour it, the syrup will flow easier out of the bottle than it will right out of the refrigerator. Well, why is that? Well, when you heat that up, you heat up those molecules. And what do you know about molecules when they're heated up? Well, they have more energy. When they have more energy, they don't get entwined and entangled with each other, and so it'll flow easier out of the bottle. Now, the same thing will happen with honey, too, if you heat up honey. So, if you want your pancakes in an easier or a better amount of time, heat up that syrup. So, what have we learned? We've learned that viscosity is the property of a liquid that describes how fast or how slow it will flow. So, we're going to be talking more about viscosity. And we're going to do a lab this week about viscosity, but we're also going to be talking about something called Non-Newtonian fluid. What's non-Newtonian fluid? That is a subject for another day. Keep thinking, keep watching, and always stay curious. By the way, see if you can figure out what non-Newtonian fluid is before we come back. That's my challenge. See you tomorrow.